2-6A, we are talking families of functions. Here's the deal with a family, right? There is a parent in a family. You do not have a child without a parent, right? So we're going to learn kind of like what this family is all about. There will be children, okay? But it starts with a parent. A parent has to have a child, right? So when we talk families, we're saying each function is a transformation of some parent function. So whatever you start with is the parent function. So we'll say the parent is the simplest. Oh, sorry. Let's get that up there. Okay, so the parent is the simplest form of a function. Okay. So every function in this family of functions that we're going to have is some transformation, some change to the parent. Okay. Think of it as you have some traits of your parent, but you're different, right? So you look similar to your parents, but you're still your own person, right? These functions are going to look like the parent function, but with some transformation that it has undergone, all right? So the two parent functions that we're going to do for today are these two. The first one is going to look like this, where you have a point here, up 1 over 1, a point here, up 1 over 1, a point there. So our parent function, where's my line, my ruler here? Okay, my parent function looks like this. Okay, and the function that this represents is f of x equals x. Okay, this is the parent function. If I plug in a 1 for x, I get a 1 for my y. If I plug in a 2 for x, I get a 2 for my y. So f of x equals x. Okay, make sure you're with me right now. There's a lot here, okay? Don't play games. So that's one parent function. And when you do graph these things, you have to plot a couple points, okay? Don't just draw a line. Show me that you knew it was 1, 1 was a point, and 2, 2 was a point, and 0, 0 was a point, okay? The other parent function that we're going to work with is a parabola. Anyone remember what a parabola is? It's the U shape, okay? So this one, the function is f of x equals, do you remember what makes the U shape? Squared. So this is f of x equals x squared, okay? But here's the thing, your parent function still, if I plug in 0, I get 0, right? If I plug in 1, I get 1. If I plug in -1, I get 1. But it's a U shape. Oops, I missed my point. Pretend I hit it, okay? So you get that U shape. So just remember, whenever there's a squared, it's a parabola. It's the U shape. It starts at 0, 0, okay, which is where we are here. When it's just like this, f of x equals x, that's a line. This is really y equals mx plus b, where the slope is 1 and the y-intercept is 0, okay? So those are your parent functions. Those are like the start. This one is linear. This one's a parabola. Okay, questions on that? Okay, everything's going to come from these parents. If the x is squared, or something with your x is squared, it's a parabola, yes. Okay, with these parent functions then, we are going to do some translations. Remember geometry last year? Remember that awesome geometry teacher that you had? She taught you how to do translations, which was a slide, right? Okay, so we're sliding today. So we are going to do a shift on the graph. We're going to slide to a new place, okay? And you can slide vertically You can slide horizontally, or you can do a combination of the two, all right? Here's how it works. You're going to have your parent function, f of x, okay? If I add, and they use k as our whatever we're going to add, if I add a k to that, so if I add something to my f of x, it's going to go vertically. It's going to go up, okay? So this one shifts up. What do you suppose happens if I subtract k?
It goes down.
It goes down. Okay, so this is a shift down. Okay. So far, so good? Okay, so that's going to be the vertical translation. We're also going to do the horizontal translation. And for the horizontal, it's going to look a little bit different. So now it's going to be f of, and in the parentheses, it's going to be x plus h. Okay? When it's inside, we're changing our x. Okay? This was more a change in our y, going up and down, right, in the overall. Now we're going to change the x itself. And this one's backwards of what you would think. So if I'm saying x plus h, I'm actually going to shift. Normally when we think horizontally, if it's a plus, we would go where? To the right. You're going to go to the left. Okay, so when it's plus, you're going to shift left.
Might I ask why?
Yep, you can ask why. Here's the deal. We're trying to get a 0 here. So if I'm at -5 for my x, then I have to add 5 to get my x to be 0. We're looking, it's essentially an x-intercept, if that makes sense. So say I was at -7 for x, I would have to add 7. Well, if I'm at -7, I'd have to add 7 to get that. 1, 2, 3, 4, 5, 6, 7. Right, would be where I end up at 0 for my x value, okay? Which is a little kooky. I know it doesn't seem right, but just remember when you're inside the parentheses, you do the opposite of what you would think, okay? So this would be x plus h. So the h is going to be our left to right. The k is our up and down. The k comes outside. The h goes inside. Good luck. Okay. Watch the video, because you're going to need to know how to do this. All right. F of x minus h, then. Where do you think you go? That one shifts right. Okay, so just remember, when it's this stuff, if it's plus, you're going left. If it's minus, you're going right, which is really opposite of the way we would expect. Okay, this one is exactly how we would expect it to be, right? Plus is up, minus is down. Be careful with those. What? You haven't been taught wrong. Now we're just looking at it in a different way. It's just a little weird. It's a new perspective, yes. Okay, so let's do a couple examples. These ones we're going to go vertical. It's going to be a vertical change here. So if we're at y equals x is my parent function. So first of all, is this going to be linear or a parabola?
Linear.
This is linear, okay? And we're going to go to, actually, I'm going to try and do all the parent functions in red, okay? We're going to go to y equals x minus 2. So can you tell me where that x minus 2 is going to put us? We're going to shift where? Up, down, left, right. Down 2, okay? So this is this one, right? We're shifting down 2. All right, so if we graph this, ooh, do I have a picture of a graph handy? Sure do. Okay, my parent function, y equals x, would be, I'm going to do this one in red, right? 0, 0 is a point for this graph. 1, 1, 2, 2. So I end up with this line. Ish. I'm sorry. Okay, I'll do my parent function is purple. Can you distinguish between purple and blue?
I mean, no, but that'll work better.
Yeah? Okay, I'll try and do parent.
Parent one is.
I'll do parent in purple.
I didn't even know you put
Parent
dots.
purple.
I just saw one.
Can you see these dots?
There it is.
Okay. Sorry, I didn't mean to forget about that. Okay, so that's your parent function. Yes, ma'am. So I just graphed this, right? If y equals x, then if I plug in a 0 for x, I get a 0 for y. So 0, 0 is a point on my parent function. If I plug in a 1 for x, then y is 1, right? Because x equals the y value, right? So you can plug in a 1, you can plug in a 2, you'll get a 2. You plug in a 3, you'll get a 3. You plug in a 4, you'll get a 4. Does that make sense? Like this, T-chart. You have an x and you have a y. If I plug in a 1 right here, y is going to equal 1 because y equals x, right? So 1, 1. If I plug in a 2, what's y going to equal? 2. If I plug in a 0, y is going to equal 0. So you're plotting all those points. 0, 0, 1, 1, 2, 2. Okay, that's your parent function. It always looks exactly like that. Okay? But now we're saying we have this equation, y equals x minus 2. Well, x minus 2 is a shift where? Down 2. What are you doing?
I'm sitting up.
So you're going to just go down 2 from those points. Down 2 here, down 2 here, down 2 here. That means my new graph, no longer my parent function, right? My new graph, except for my line doesn't want to draw straight. Pretend that's straight. On the right slope. It's slightly off. But that would be my translation. That would be my slide. Okay? So it slid down 2, but it's exactly the same graph. Okay? How about this one? If I give you y equals x squared. Oh, that's supposed to be purple. That's my parent. Y equals x squared is my parent. And then we have y equals x squared plus 3. Where are we moving for that?
To the left.
Up 3, right? It's not in parentheses with the x. It's outside of that, plus 3. So this is going to be 3 up, okay? So if we take our graph, okay, y equals x squared. If you plot y equals x squared, you can do the same thing. If I plug in 0 right here, 0 squared is 0. If I plug in 1, 1 squared is 1. What if I plug in negative 1? Negative 1 squared is 1, right? So your parent function would have a point at 0, 0, 1, 1, negative 1, 1, and it's the x squared is what shape?
A U.
A U. So you get this U-shaped curve, okay? I don't need all the points. Just give me 3 points, okay? So there's your parent function. From that, we're doing a plus 3, which moves where? Up 3. So just take those 3 points and move them up 3. 1, 2, 3 would put my middle point there. 1, 2, 3 would put my middle point there. 1, 2, 3 would put my left point, my right point, and then you just make your U curve. Okay? Piper.
Can you explain one more time why that's not linear and it's a parabola?
Because it's got the x squared. Like if I kept going here, say I plugged in a 2. When I plug in a 2 here, 2 squared is 4. So it's not going to make a straight line anymore because if I plot the point 2, 4, 1, 2, 1, 2, 3. Oh, look at that, guys. I went perfectly through it. I can't draw a straight line through all of that, right? So whenever it has that x squared, it's exponential. It moves quicker the more you move out, okay?
Would there ever be like numbers in place of the variables?
No. No. You'll always have your x and your y in there. Okay. So let's ditch the graph for a second. Oh, guys, we gotta move. Okay, we're not gonna graph these. I wanna know if you were gonna go up 5, and my equation was this, y equals x squared minus 1, okay? Here's the deal. If I'm going up 5, what am I doing to my parent function? Am I adding or subtracting? You're adding, okay? So if I want to move up 5, no, that's left and right is opposite. Up and down is the normal, okay? So if I want to go up 5, I need to add 5 to this function. Well, negative 1 plus 5 is going to put me at y equals x squared plus 4. So this would be my new equation if I shifted it up 5. Does that make sense? We just add the 5. Andrew, are you with me right now? You are going to have a tough time with this if you do not pay attention right now. Okay. If I want to go, no, we got to keep going. Okay, horizontal. This is the one that's a little confusing, right? When we go horizontal, let's say I start with f of x equals x squared. Okay, that's my parent function. And I'm going to go 7 left. Okay, if I'm going to go 7 to the left, normally left would be subtraction, but we're going left to right, which is opposite. So you're adding, and it's inside the parentheses this time. So it's going to be f of x equals x plus 7 squared. That would move me 7 to the left. So if I were to plot that, my parent function, and just sketch graphs for this, that's totally fine. You can just sketch them. Okay, my parent function is this, 0, 0, and the parent, notice this, the parent function never changes. It's always the same. 0, 0, 1, 1, negative 1, 1, right? I get my U-shaped curve. I'm moving that 7 to the left. 1, 2, 3, 4, 5, 6, 7. Up 1 over 1, up 1 over 1. That's my new graph. Not really. I'll go back to it at the end, okay? Questions on that?
Why did it go to the left?
Because we added 7, and you're trying to get a 0. You're trying to get your x-intercept, right? Where x is, you're trying to get to 0. So negative 7, right, plus 7 would put me at 0. We want our x to be 0. We want our y, sorry, I'm saying that wrong. We want our y to be 0. It's where we hit the x-axis. So we want this to equal 0.
I know, but why? When did x become negative 7?
I'm plugging that in to make it a 0.
Where? Oh, does that?
That was part of the parent function. The squared was part of the parent function.
Okay, how do you know it's in like parentheses and then squared? Is it just whenever it becomes x squared?
When it's inside parentheses, that's left to right. When it's outside the parentheses, that's your up and down.
When do you know that it goes inside?
Or outside?
Because I said 7 to the left.
So just say in the directions.
So left and right means you're going to put it inside.
Okay.
If you're going up and down, you're going to put it
It'll be up.
outside. You'll be told where you're moving.
Okay.
Yeah. Or you'll get it and you'll need to know where you're moving. Okay? Okay. One more. This one is a combo. Okay. Yeah, so be quiet and listen and we'll get through it. So if we have this, y equals x squared is our parent function. Okay? And then we get this from it. Okay? Tell me where you're moving for this. What is this telling you?
You're going down 4 and to the right 3.
You are going down 4, okay, because it's outside of your squared. This one Inside the parentheses is your left and right. Andrew, you don't need that right now. You need this right now. Inside, okay, this minus 3, you would expect to be left, right? Correct? It's to the right, okay? It's opposite. This one you're going right 3. So if my parent function, don't talk, just listen. If my parent function is this, right? My parent function is never changing. This is a squared, so it's the U-shaped curve. Okay, there's my parent. I need to go down 4. Down 4, 1, 2, 3, 4. Puts me here, but that's not my point because I also need to move to the right 3. 1, 2, 3. This is my new point. Excuse me. Okay? So if that's my new point, and now I finish off so it looks just like my parent function. There's my other 2 points. That would be the graph of this. Okay?
So even if the 3 is in the parentheses and the squared outside, the square doesn't apply to the 3?
You're not squaring it because we don't know what x is, right?
So how come we don't just say x squared?
X minus 3 squared is not x squared minus 9, right? X minus 3 squared, you have to remember FOIL, first, outer, inner, last. We're not doing that.
X squared minus.
Don't do that. That totally changes your problem. We're not doing that, okay? Okay, here's the deal, guys. This is what you need to know. If you know this, then you can do all of this. If it is outside of your x, it's up and down. And you follow plus is up, minus is down. If you are like this inside, then just go the opposite direction, but you're going left to right. Okay? Good?